Welcome to the Data Literacy Lesson Summary. As a data scientist, you need an awareness of data storage, possibilities for its organization and management, and options for retrieval. These systems enable you to find and analyze the data you need to make great discoveries hidden in that data. In this video, we'll summarize what you learned in this lesson about the technologies and tools to handle large amounts of data. Let's consider data repositories. These repositories need the ability to find the data you want and return it to you in a usable format. Your data type helps determine the type of repository you need. You can store structured, semi-structured, or unstructured data. Depending on the organization, you may need a relational or NoSQL database. For big data stores, your needs may call for a data warehouse, a data mart, or a data lake. Relational databases store structured data. These are the oldest types of repositories. The most conventional and frequently used relational database management systems, often abbreviated as RDBMSs, are based on the foundational concept of structuring data in a tabular format with data arranged in rows and columns. Each table usually relates to a topic, and the columns of data in the table contain a specific type of information related to that topic. Then, the database contains a defined schema that describes the table to each other. Relational databases usually rely on structured query language, or SQL, to search for and retrieve the data you need. You use SQL to manipulate the data. Relational databases are beneficial for visualizing, analyzing, and finding connections between different pieces of data. You link tables together by creating schemas. You can restrict database fields to specific data types and values, which minimizes irregularities and leads to greater consistency and data integrity. They offer easy export and import options, making backup and restoration easy. However, RDBMSs do not work well with semi-structured or unstructured data. They are also slow to query with enormous datasets. Since RDBMSs use predefined structures for data to reside in, it becomes problematic when the data evolves and no longer conforms to that structure. Relational databases also limit field length, which means that sometimes they cannot accommodate the information you need. Because of these limitations and the quantities and diversity of data collected, many organizations have turned to not only SQL databases, or NoSQL for short. Built for speed, flexibility, and scale, non-relational databases allow storing data without stringent schemas. They can house semi-structured and unstructured data. NoSQL databases include document-based, key-value, columnar, and graph. Document-based databases store semi-structured documents such as JSON files. You group documents into collections, and each document has its structure. Key-value stores each piece of data as a key-value pair, so you retrieve and update the data using the key. Columnar databases store data in columns rather than rows, enabling storage of large volumes of data suitable for analytical workloads. Graph databases store data in nodes. Nodes have relationships and properties and can manage and query complex relationships between them. You can use technologies such as data warehouses, data marts, and data lakes for high volumes of data. A data warehouse works like a multi-purpose storage for different use cases. The data has already been modeled and structured for a specific purpose. As an organization, you would opt for a data warehouse when you have a massive amount of data from your operational systems that must be readily available for reporting and analysis. A data mart is a subsection of the data warehouse built specifically for a particular business function, purpose, or community of users. A data mart offers analytical capabilities for a restricted data warehouse area, offering isolated security and performance. A data lake is a storage repository that can store large amounts of structured, semi-structured, and unstructured data in their native format, classified and tagged with metadata. Let's review storage options. Data pipelines address an organization's need to collect, transform, and move data. Data pipelines have multiple steps, providing a systematic process to handle massive amounts of data as it is continually collected, processed, and made available. ETL, which stands for extract, transform, and load, is a subset of a data pipeline, referring to an automated process where an organization converts its raw data into data ready for analysis. So now, as a future data scientist, you are aware of many technologies needed to handle big data before analysis can begin. These include data storage, organization and management, and retrieval. Data storage options depend on the type of data, its volume, and how you intend to organize it. Using a data pipeline such as ETL provides a process to manage and retrieve the data so you can analyze it as a data scientist.